This episode of CppCast is sponsored by JetBrains, maker of excellent C++ developer tools, including CLion, ReSharper for C++, and AppCode. Start your free evaluation today at jetbrains.com/cppcast-cpp. Episode 84 of CppCast with guest Brittany Friedman, recorded January 4th, 2017. In this episode, we take a look at a new tool for C++ bloggers. Then we talk to Brittany Friedman from Gearbox Software. Brittany talks to us about her accepted C++ 17 proposal and much more. Welcome to episode 84 of CppCast, the only podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
Good. Had a busy holiday. How about you?
Same here. Traveled up to New Jersey and back, like I mentioned before. Had a pretty good time. Saw the family.
That's right. You were looking forward to Christmas in New Jersey.
Oh, yeah. So you had a good holidays, though?
Yes, I did.
That's good. Well, at the top of our episode, I'd like to read a piece of feedback. This week, Daniel writes in from Germany saying, "First of all, love the show. Great work. Keep it up. And I have a small feedback for show number 81 with Nicholas Fleury. You discuss string implementations and avoiding the heap by using and even extending small string optimization. I recently published a small library that has a stack-only, heap-free string implementation, which basically is a standard string-like interface around an ordinary character array. It can be useful for optimizations and migrating legacy C code. You can find it, and it has a link here, which I'll put in the show notes. And if any of you or Nicholas have any use for it, cheers and thanks a lot for the show." So yeah, we talked a bit about string optimization based on one of the talks that we all watched at CppCon.
Yes, that's right. That's a really good talk.
It is a very good talk, and it's a short one. It was only, I think, a 25-minute talk, right?
Something like that. It was
like
after our talk, so it couldn't have been more than an hour, or more than half hour.
Right. So yeah, always good to look at these small optimizations. I know they can really help, everyone's using lots of strings, so...
Well, and that interesting about that kind of thing, a small stack-based character array string implementation, could be made fully const-expr. I don't know if that implementation is. And there's some very interesting possibilities there.
Interesting.
Assuming it cannot grow beyond the fixed array size.
Okay. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us reviews on iTunes. Joining us today is Brittany Friedman. Brittany is a dense collection of matter formed from molecules originating inside the sun. She currently works as a programmer at Gearbox Software, where she weaves ones and zeros into intricate little patterns. Her proposal for new memory management algorithms was accepted for C++ 17, and a bug that she filed against the C++ standard was fixed the way that she recommended. So basically, you do not want to trifle with her. Brittany, welcome to the show.
Hey, guys.
So, okay, what was the bug fix that you got in the standard?
Yeah, okay, so the part of the standard that I was working in for my proposal, I was just working along in it, and I happened to notice something really weird, which was standard address of. It's a handy little function for taking the address of an object. I noticed that you could pass an R value into it, and it would be totally okay with it. So you could pass a temporary object into address of, and it would take the address of it.
Huh.
And that's kind of a problem, because you should not be able to take the address of a temporary.
Yeah.
Yeah. So, that was my bug. And my recommendation was to add another template, basically an overload, that would be deleted if it was an R value reference.
Interesting.
Yeah.
Oh, okay.
So, nothing too crazy, but something that's kind of flew under the radar for half a decade. And,
yeah.
So, pretty good. Pretty good
Very
little
cool.
change, I think.
That's amazing how many of these tiny little things are going into C++ 17 that would be nearly impossible to keep track of all of them.
Oh, yeah, absolutely. There's a lot of people working on it, and there's so many little edits. You tend to get a lot more with any standard than you realize, than anyone reports on necessarily, especially in the realm of bug reports.
Right. Okay, well, Brittany, we have a couple articles to discuss. Feel free to jump in on any of these, and then we're going to start talking to you about some of your other standards work and some of the work you're doing at Gearbox, okay?
Yeah.
Okay,
cool.
So this first one, we actually talked about this last week too, Jason, and this was about the podcast awards, the Software Developer Podcast Awards, and we were kind of joking about it last week because we were... and are the only podcast in the C++ category. So they had these category by category votes, and we did, of course, win for C++.
Yes.
Podcast. Yeah. Congratulations. So what they're doing now, though, is they took all of the category winners, and they're now holding a second vote for best overall podcast. And last week we kind of jokingly said we had some stiff competition. This week we really do have stiff competition. I'm not really expecting a win on this one because some of these podcasts have been along for quite a while. But we'd still appreciate if our listeners would get onto the website and vote if they're interested.
Yeah, vote early, vote often, as they say, right?
Yeah, exactly. But yeah, some of the podcasts we're up against, I know I've heard of before, .NET Rocks. I think they were around before podcasting was called podcasting.
Oh, so goodness.
Pretty impressive. I think they've been around for like 12 years or something.
That's older than you are, right, Rob?
No, it's not. Although I guess I was in school then. Wasn't programming professionally or anything then, yeah.
Sorry, I couldn't resist.
It's okay. Well, let's get on to the other articles. The first one is Keep Disabling Exceptions, and this is an article from Sean Middleditch, and I'm guessing you probably have some comments on this one, Brittany.
Oh yeah, definitely. I work pretty closely. Well, I work a lot with Sean in SG14, so we talk a lot about this kind of thing.
Yeah, and this was a response to someone else writing an article saying to stop using F-no exceptions, and he obviously disagrees with that person's perspective on it. Yeah.
We might be jumping a little ahead of ourselves here, but you do game development. Do you compile with exceptions on or not?
I think there's an important distinction to make here. The distinction is, do you use exceptions, and do you compile without compiler support for exceptions?
Right.
And those are sort of different because if you use the standard library, they throw exceptions in all sorts of places. Right. And some compilers are not very happy if they see a throw statement when you're compiling with throwing disabled. So I've never worked on a project that used exceptions extensively. That doesn't mean we always disable exceptions. For example, the Xbox One, as I recall, uses exceptions pretty heavily in some of their code. Yeah. Huh. As part of like Microsoft's deal, which may be inherited from WinRT, I don't know. But, but we avoid it in as much code as we can. And I generally agree with that. They're really a problem. In particular, or at least the reason I don't like exceptions, if you robustly support exceptions, if you're going to try to provide exception guarantees, like a basic or a strong exception guarantee, you basically have to look over every single line of code in your program and say, what if an exception is thrown here?
Right.
At least if you're writing generic code, right? If you don't know exactly what's going to happen, if you're calling random function X, and function X might throw because it's customizable. That's so much brain overhead for me. Maybe I'm just not smart enough, but that's like so much to have to deal with. And then there's the documentation problem of saying these are the exception guarantees. These are when you're allowed to throw. It's really hard. It's really hard. It's so much easier just to say, no thanks, we're passing on exceptions. And that's the sense that I sort of agree with this.
Yeah, it makes some sense. One of my favorite C++ 17 features that's coming up is the no discard. What do you call that?
Attribute?
Attribute, thank you.
Yeah, that's the one.
Just went right past my mind right there. The no discard attribute, which she mentions in this article, and I think that can go a long way to reducing the use of exceptions where we want to say, you cannot ignore this error. Well, now there's a way to say an attribute. Now you can't ignore the error.
Yeah, definitely. It'll help us write better APIs.
Right.
And better APIs may reduce our dependency on exceptions in some ways.
Right. Okay. This next one is an article written from our recent guest, whose name I just blanked on for a moment, Phil Nash. Phil Nash. And he's writing C++17, Why It's Better Than You Might Think. And what was your take on this one, Jason? It was basically, he mentioned the article we talked a little bit about 2 weeks ago about the C++ standards meeting, and he's kind of going over how maybe it's not such a bad thing if, modules and coroutines and ranges didn't make it into C++17, just because we're kind of still adjusting to C++11 in a lot of ways as a community.
Yeah. I mean, I agreed with the article because, we're getting caught up in the these big features that we were hoping in C++17 didn't make it.
Right.
Coroutines, modules, and concepts are like the ones that people want to talk about. But all of these little things that Phil mentions, context per if, destructuring, or structured bindings, whatever you want to call that, I think they're going to add up to changing the way we program in C++. And it's something I've been playing with lately, and I think I agree with him. I think there's enough here that it's going to keep people busy for a couple of years, basically.
Right. How about you, Brittany? What are your thoughts on this as someone who got a proposal into C++17?
Well, okay, so there's a lot of people who are expecting C++17 to be a so-called major release.
Yeah.
This sort of model where we have major and minor releases of C++. 03 was minor, 11 was major. And if you follow that sort of cadence, 14 would be minor and 17 would be major, right? There's sort of a natural expectation there that C++17 should be huge. That's completely the wrong way to think about this at this point. We're no longer working in the realm of major releases and minor releases. It's more of an agile methodology, I think, at this point.
Right.
Every some number of years, they're targeting 3 years. Every 3 years, they'll release a standard. If your favorite feature doesn't make it, then maybe it'll make it next time. But I think the intent here is going to be good for C++ in the long run. It just means that there's a problem of expectation management. And I don't want to say anything about Bjarne Strustrup. He's a great guy, but he did write that post that said all the 10 great things I want in C++17. I think his intent there, I can't speak for him. I think his intent was to sort of push the committee in a direction and encourage them and focus the committee toward, some goals. But a lot of people saw that and saw it as a promise.
Yeah.
And that was really a problem. So I don't consider this his fault by any means.
It's worth keeping in mind, wasn't that article just intended for the committee members and it kind of got leaked out and everyone caught wind of it, right?
I think so.
Yeah.
It's hard to write anything. Look at last year. You can't write anything on the internet without everyone seeing it.
That's true.
I think there's sort of a problem in C++ just of expectation management, of public relations.
Yeah.
And that's sort of a role that Herb Sutter has fulfilled for years and years and years for C++. We probably need more voices who are in the committee, making an effort to really shine a light and communicate the things that are happening and communicate proper expectations. You want to do that?
Yeah.
Well, maybe we're doing our small part. I don't know.
Okay. I think you are having a pretty good role here. But yeah, it's a hard problem. But I think it's way more useful to talk about, I wanted feature X and I'm disappointed, as opposed to C++17 is small and I'm disappointed.
Yeah.
So if there's particular features you want to be in the standard, All I can say is either have patience or try to make an effort to help out. And there's so many ways you can help out. Help out with implementing the feature. Help out just editing. Like, contact the person writing the proposal and say you're willing to edit for them. There's tons of things that can be done. But it's certainly easier to complain. And it's easier for the committee to focus on, them trying to get the proposals out as opposed to, bring new people into the fold that can help.
Right.
There's only so much any of us can do. We're all just volunteers. So, it's a tough problem, but I think communication will be really key to at least improving attitudes, across the board.
Right.
Right. Okay, this next article is a new way of blogging about C++, and I thought this was pretty cool. This is I guess it's a JavaScript plugin that you can include in any, HTML blog website. And it basically allows you to write a snippet of code in C++ and have it so that code is evaluated and, the results of it are displayed in the blog. And the really cool thing is you can make edits to it and it'll immediately reevaluate the code.
Yeah, it runs really quick, that's for sure.
Yeah, I was playing with the Fibonacci generator here and just changing a number of the number of Fibonacci it counted up to, and it reevaluated it pretty quickly.
Yeah, it's pretty cool. I at least one thing that sort of annoyed me about it was that didn't seem to be a reset or a way to compare. So you can you change all the code and you can't really go back,
right?
At least without refreshing the page. And I think about this. We have Godbolt, which his online compiler, which is incredible. And
Yes.
it shows you the assembly, which is incredibly useful, but it doesn't execute. At least I don't think it executes the results in real time. This is sort of the opposite. So, I mean, ultimately, where's this headed? Where is this sort of technology headed? I think we want like a plugin, a Firefox plugin or a Chrome plugin, which is just Visual Studio, just sitting there inside your web browser. And, but I'm serious. Like ideally, like if we're going to have this feature, which I think is really cool. I think it's really cool. One thing I'd really want here is, the ability to set a breakpoint, right?
Yeah.
Because
Right.
the whole point of this is you're testing out something maybe you don't understand. This is a new feature. You want to like play with it a little, and breakpoints are sort of how you play with code.
Yeah.
So that would be a real big thing here. And, eventually we're talking about, implementing a full featured compiler, front end, back end, the whole 9 yards. So maybe, I don't know. I'm just talking out loud, but.
Why don't we just recompile gcc or Clang with Inscripton and run it in the browser?
Well, yeah, I was
That's
thinking about that with
absolutely a possibility.
WebAssembly. We're going to be able to put all the compilers into the browser if we want to, right?
That would be so huge.
Yeah.
Now, correct me, please, if I'm wrong here, but on this C++ page we're talking about, I don't actually see a single feature of C++ that it supports except for cout.
Yeah, and
Like
actually,
if you type class, it fails to compile.
Oh, wow.
he mentions at the bottom that it's a partial implementation of C++. So I didn't realize it couldn't do classes. That's pretty partial.
Yeah, I looked at the what features are implemented.
Okay.
Yeah, here we go. Operators, primitive types, variables, arrays, pointers, if, else, switch, for, while, do, functions, variables, and preprocessor directives.
So it's really more like C.
Yeah, it's really more of a C, but it's still cool.
Yeah, it's still cool.
It's very cool.
I definitely
all
had the
start
same
somewhere.
thought as soon as I saw it. I was wondering if we could get Godbolt into a blog post the same way that this did it.
Yeah, as I understand that project's open source. The Godbolt compiler is open source. So if someone is willing to put in a little elbow grease, I bet you could make an equivalent sort of little embedded feature in your blog.
Well, he does have an embedded one that you can show the source and the assembly output, but not the execution of the program.
Sure.
Does that do live changes, or do you need to go back to the Compiler Explorer website to make changes to it?
No, it's actually live. I suggested to him that he might want to do like a screenshot or something just to reduce server overload, but yeah.
Very cool. Okay, well, Brittany, let's start talking. Let's start off by asking a little bit about the game development work. You said you work at Gearbox Software, right?
Yeah.
So what games have you worked on there?
Okay, so yeah, I joined Gearbox about 7 years ago, which is a pretty long time to be at the same company, especially in the game industry.
Yeah.
I joined the company to start work on Borderlands 2. They hired me to help make Borderlands 2 possible. And since then, we've had all sorts of DLC, or as they used to be called, expansion packs, for Borderlands 2. And we made the pre-sequel and all of its DLC. And I also worked on Battleborn. So it's a pretty good chunk of stuff I've had there. And we've released other things in that amount of time, but those are the only projects that I've directly had sort of my hands get dirty in. And it's been great. It's been really fun.
I don't think I've heard of Battleborn. I see it now on the website.
Uh-huh. Yeah. Battleborn is maybe not as... The diplomatic way to put it would be it's not as well known as some of our other
Yeah, I'm definitely familiar with Borderlands, although I don't think I've played through the entire game.
You definitely should. Okay. I would highly recommend it. We get some profit sharing here at Gearbox, so
really?
It's my duty to encourage you to purchase. In fact, you should get multiple copies. Really, I would.
That leads right into the next thing I wanted to talk about is, what's the culture like from your perspective working in the games industry? It sounds like if you get some profit sharing, it already sounds better than some of the horror stories I've heard.
Well, Gearbox is very peculiar in that we get profit sharing. That's pretty much unheard of in the game industry. It's a very special feature that we have. So yeah, I mean, overall, the game industry has been really interesting. In some sense, it's really hard for me to compare with what other industries have, because this is the only industry I've worked in.
Right.
So, if this is all you know, it's hard to say if it's good or bad. It's just all you know. But, from my understanding, it's not entirely dissimilar from a normal quote unquote software project, but there's definitely some peculiarities. We've got, around, it's like 250 to 300 people employed at our company.
Wow.
That sounds pretty good.
Yeah, it's considered medium size in the game industry.
Okay.
A big company would be 1,000 people working on one game at a time.
Wow.
Yeah, I know. And we have the numbers I'm giving are pretty rough, but I believe we have around 100 artists, including animators, 3D modelers, texturers, people who focus just on lighting a scene to make it look good.
Wow.
We have somewhere around 30 or 40 programmers. So in that sense, it's maybe more reasonable if you're only thinking about the programmer side. Mm-hmm. But it can be, it can still be really tough because, I make a change to our source code that prevents artists from being able to do work, which is so easy to do. It's incredibly easy to do. Oh yeah, you're going to be really popular, or God forbid you, cause them to lose their work, whether it be a crash or you serialize information incorrectly. You're going to have a lot of people who are unhappy with you, a lot of money that can get lost very quickly.
Do you want to tell us a little bit more about what exactly your role is at Gearbox?
Yeah. For most of my time at Gearbox, I've been a tools lead, which is probably the worst position to be in as far as this discussion we're having. I was basically the point of contact for whenever the artists weren't able to get work done, more or less. So yeah, tools in the game industry, at least at Gearbox, is talking about the art pipeline. So how do we get art assets into the game? How do we build stuff inside the game? How do designers specify how much damage a gun does, or how does a designer specify the AI behaviors of this new monkey enemy we're making, or what have you. And it's incredibly detailed. So many different pieces to game development, vehicles, at least to our games. So many pieces, missions, vehicles, the projectiles that fly through the air, the skills, the players, the worlds. So many different things. Incredibly diverse, really interesting. It's also really stressful. You can imagine with so many people depending on you, with, looming deadlines all the time. It's never a dull moment, I guess would be the right word, right?
Sure.
Yeah, it's really special. And it's sort of from that, situation that you get crunch. It's from something went wrong and you lost a day of work. It's from, I don't want to check anything in this week, or I don't want to check this change in this week because it's kind of dangerous. So I'm going to check it in over the weekend.
Right.
And that totally makes sense because no one's working on the weekend, or very few people are. You're minimizing the risk. So I've never had someone come to me and say, hey, you have to work this weekend. I've never had someone say, sorry, you got to put in 60 hours this week. It's on my budget. You just have to do it. But deadlines can get really strict. I once had a deadline that was, this needs to be done by 9 a.m. Monday morning.
Mm-hmm.
Which is pretty much telling you to work on the weekend.
Right. And you were told at 4 p.m. on Friday?
It wasn't that bad, no. I had a few weeks notice ahead of time.
Okay.
It's tough. It's tough and it can be really stressful. But, and this peculiar feature of Gearbox that I spoke about, where we get profit sharing, that can encourage you to crunch a little bit more.
Right.
Because if the game does well, you're going to feel it in your bank account. So in some sense, that can make all of it a little bit more worth it. It might also encourage at least certain personalities to work a little bit more than they would otherwise.
Right.
So, but it's going to be different everywhere. And it can vary a lot. Sometimes, your deadlines are directly tied to company, profits, based on how, the contracts are laid out between you, your game studio, and the publisher. I can't say anything about Gearbox's profit model here.
I know you want to publish games right before Christmas and that sort of thing.
There's definitely that.
Yeah.
There's also, or you don't want to release a game too close to a competitor's game.
Yeah.
There's also a situation where the contract may specify that, the company gets money based on making its milestones. And so if you fail to meet your milestone, you might get less money from the publisher, or they might just drop your money that milestone. Sorry, try again next milestone and maybe we'll pay you. Totally depending on the contract situation. So, yeah, there can be a lot riding on this in ways that maybe are not as common in other fields of software, but I don't know. I don't really know how. I've never been in another industry, so maybe all companies are like this, but I get a feeling like it's a little bit different in the game industry.
I'd like to interrupt the discussion for just a moment to bring you a word from our sponsors. C-Line is a cross-platform IDE for C and C++ from JetBrains. It relies on the well-known CMake build system and offers lots of goodies and smartness that can make your life a lot easier. C-Line natively supports C and C++, including C++ 11 Standard, libc++, and Boost. You can instantly navigate to a symbols declaration or usages too. And whenever you use C-Line's code refactorings, you can be sure your changes are applied safely throughout the whole codebase. Perform unit testing with ease as C-Line integrates with Google Test, one of the most popular C++ testing frameworks, and install one of the dozens of plugins like Vim Emulation Mode or Go language support. Download the trial version and learn more at jb.gg/cppcast-cline.
So you said you work on the tools and how assets get into the game, and you mentioned just briefly like AI and like specifying things like how much damage does a gun do or whatever. I'm really curious, how actually do you specify those things? What solutions have you come up with, scripting or whatever, if you can talk about it?
Oh yeah, definitely. So That was pretty much what I did did at Gearbox for pretty much the entire time I've been here. So the way that it was done at one point before I joined the company was basically we have an editor, a large editor with 3D viewports and has all the assets listed and that sort of thing. We've until recently we've used Unreal 3, the game engine Unreal 3. Mm-hmm. But these game engines aren't built for making our game. They're built for making they're a generic platform for game development. So you buy a game engine, it's not going to have, here's where you make character skills, and here's where you specify how much damage the gun does. A lot of that stuff has to be built on your own because it's sort of a generic foundation you're building on. So before I joined the company, it was basically spreadsheets was how it was done. We'd had spreadsheets inside the editor, and designer would find the appropriate cell in a spreadsheet and type in the number and then play the game and see if they like it more than they liked it before.
Huh.
Which is, spreadsheets are incredibly powerful. You can do anything with a spreadsheet, but, it has limitations once you reach a certain level of complexity. So, most of what I did at Gearbox was developing visual scripting languages, for all these different things. So for example, we had AI programmers who were focused on, how do we get AI to animate smoothly and, react to threats and that sort of thing. But when it came to sort of the integration with designers, I would be making a visual scripting language, or at least helping the AI team make a visual scripting language to define, a very domain-specific language for this is how AI works in our game. We used behavior trees. So we built a specific scripting language just for describing how enemies act. And then we built another scripting language for designers to specify the structure of a quest in our game. And then we built another domain-specific language for general scripting purposes.
That's interesting.
And yeah.
So you've developed multiple domain-specific scripting languages instead of, using something more common like Lua, or?
Yeah, because there's a couple of pieces here. At least our designers don't have, very, very few of them have any programming background whatsoever. In fact, if you ask them to open up a text editor, they will freak out. They're just, they don't like it.
Yeah.
So yeah, we needed something visual, and, maybe we could have tried to build like a visual scripting language on top of Lua, maybe, for example. But, almost all of our needs are domain specific. Lua is not great for describing a behavior tree, because these are sort of very specific data structures that we're building. So, we've got this rich, robust UI that we can add arbitrary complexity to, and in the back end, where the game actually runs, we have a specific data structure that the AI team wants filled in.
Mm-hmm.
And that's sort of, we essentially have a compiler which converts this visual scripting language into the data structure that the AI team built. And they need this because the AI team wants to be able to say, okay, here's our behavior tree. I need to know what's going to happen, 3 nodes down, or what's going to happen if I take this branch. They want to be able to sort of analyze the data, to get useful information out of it. And if it's just arbitrary source code, that's really hard.
Right.
It's really hard. If you just have a Lua function and you want to know some intricate detail of what's going to happen if I call this function, that's a really hard problem. If you make a specific data structure, that's really easy. Just read the float or what have you. So that was sort of our motivation for all of this. And it was really successful. At least if you look at how much content there is in Borderlands 2 versus Borderlands 1, that will more or less be a testament to how how well this idea went. So I think it was good.
So oh, sorry, go ahead.
No, go ahead.
I was just going to say, the easier the tools are that you create, the more content your designers are going to be able to get into the game.
100%. 100%. And something that's a little bit weird about being in tools is no one else can get work done until the tools are ready. Right?
Right.
No stress.
Right. You can't write a novel if Word doesn't load. Right? So, and that's effectively what my role is. I'm making Word so that the designers and the artists can make the novel. So I had a tendency to crunch more at the beginning of a project to get everything ready to go, as opposed to crunching at the end of the project, though I would often end up crunching at the end of the project too for other reasons. But the bulk of my work was front loaded, and so that other people could actually could get started making the game.
Interesting.
So do you want to tell us a little bit about the proposal you got in for C++ 17? We already talked a bit about the bug fix, but how about the larger proposal?
Sure. It's not really a large proposal, but I'm proud of it, so that's what matters. So one of the things I've done at Gearbox, so like I said, I was the tools lead, and at least the structure of the engine we used, it meant that the more you know about the tools, the more you know about the game, because they were a shared code base.
Okay.
It was all just one giant code base that had the editor and the game runtime all together. So as things go wrong in the tools, I would end up learning things incidentally about the low-level game systems and the low-level engine, just because it was all shared. So I ended up sort of a little bit transitioning from pure tools to also doing low-level engine work. Okay. And it was through that I started looking at some of the containers that we wrote, our version of standard vector, and, trying to improve them, make them a little more efficient, that sort of thing. And I noticed, we had some algorithms in here that were very similar to, or some functions that were prime for being made into something like a standard library algorithm. So I sort of separated those out, made them nice little algorithms on their own right, and then did some research and found these are used everywhere. These are really commonly needed, especially for people implementing containers. So for example, in our vector class, one of the things you need to do in a vector is default or value initialize the objects. So you construct the container, and then you want to fill it with 100 value initialized objects.
Okay.
That's a loop from beginning to end where you do something to each element, and it's an algorithm. So that was one of the algorithms that I identified as being useful, and that I identified as tons of other companies were using by, some other name, often not a separate function, just, incidental in the middle of their code. So I said, these would probably be worthwhile standardizing, because they're very similar to some existing algorithms that were in the standard. So I said, why not see if the committee would like these? So we got an uninitialized move for move constructing objects into a range of uninitialized memory. We have standard, uninitialized value construct. And that's for value initializing objects. Uninitialized default construct for default constructing, and destroy for destroying a range. That would be your vector destructor, destroy all the objects in the vector. And destroy at, which just calls a destructor on a single object. So that was sort of the motivation. I ended up finding I ended up rationalizing a lot of good reasons for it to exist and finding all sorts of examples of this stuff on GitHub. Wrote a proposal, found its way in somehow. It was a great experience, definitely, and hopefully it was for the good of C++ as a whole. I think it was.
So you're not actually are you on the committee?
Well, that's a really interesting question.
Okay.
It's not entirely clear to me what it means for someone to be on the committee. What I think it means for someone to be on the committee is that you are part of the registered ISO bigwigs. That's a very formal process,
right?
And it means you have voting rights as far as what actually makes it the final step in the process. So no, in that sense, I'm not a member of the committee. I'm someone who showed up at one of the committee meetings and strong-armed them into accepting my proposal.
So that was your first experience with the committee then, I take it?
In person, absolutely.
Okay.
Yeah. I'd met some of the people involved, or some of the people at least that helped me. I'd met at CppCon. You should definitely go to CppCon.
Yes, you should.
For anyone who hasn't been. So that helped, that sort of networking helped me get the process started. And some of the people in SG14 that I work with, in that regard, were instrumental in helping that process along. But yeah, when I actually ended up flying to Finland, that was my first interaction with the committee. Yeah.
Were you already involved with SG14 at the time that you discovered all these algorithms in your code base, or did that prompt you to look into SG14?
No, I was already starting the process. SG14 hadn't really got off the ground a whole lot.
Okay.
At that point. But yeah, I was right there from the beginning. And we were actually having a discussion on the SG14 mailing list. The technical term for mailing list is reflector, by the way. The SG14 reflector.
Did not know that.
I know, right?
And we still don't have reflection, so...
I know. Well, we actually have a reflection reflector, I think. So we're on our way there. Yeah, so on that mailing list, we were discussing, we often use optimized containers in games industry, ones that don't throw exceptions, ones that maybe can do default initialization instead of value initialization. Maybe they use a different allocator model. All sorts of things that we do differently, often with our vector. Just tiny tweaks, but they can make a big difference. So we were discussing the ideas about maybe proposing new containers. And I said, well, how about we start off with proposing pieces that can help other people implement containers. So instead of making these huge controversial decisions about new allocator models and never throwing exceptions and that kind of thing, like the kind of stuff no one wants to debate because it'll go nowhere.
Right.
It's much easier to provide these little library pieces to help us and other people, library implementers, make their lives a little easier when they are making these specialized containers. At least make the process easier, less error prone. So that was sort of where that sort of originated from. And my experience with SG14 was great. My experience with the committee was generally good. Yeah.
Well, that kind of leads into another question we had. What was the process like getting your proposal accepted? Did it take multiple revisions?
Yeah, it's not an easy process.
Okay.
I may ramble a little bit, so feel free to stop me because this is an arduous process, and I can go through it step by step if you really want to, or I can try to give you the abbreviated version. But I suspect maybe some people would be interested in knowing the full rigmarole. Okay, so you start off the process with thinking about it. That's usually a good starting point. Thinking about your proposal, and once you've got a good sort of baseline, a good foundation for your idea. There's a reflector, a mailing list, called STD proposals, and that's where you're supposed to start off a topic, talking about, hey, I've got this idea. From there, you'll get feedback. People will say it's a terrible idea. Mailing list tends to be a little negative. So, be strong. My proposal was really simple, so it didn't get that much blowback. But yeah, you'll propose it there, you'll get feedback, alternative implementation ideas, people saying it's not worthwhile, people saying we really need this, what have you. Ideally, you'll incorporate all that feedback into writing a proper document that is formatted according to ISO rules and fully presents your idea in the way that they like. So once you've got a paper that you feel like is ready, I want someone important to look at this. Then there's an email address you'll submit it to. And that person will take the document and include it in the next official mailing. There's like a bulk mailing of all of these C++ proposals that happens, I believe, quarterly. So, and I don't know if that's really a necessary part of the process, but the more of these steps you follow, the better of a chance you have of getting it in. So that will get a lot more eyes on your proposal if it's in this official mailing. From this point, you're doing good. You're about 10% of the way there. Now, I know, right? So, your next step is to get people at the standard committee talking about your proposal. So, either you need someone to actually attend these meetings in person to so-called champion your paper. This could be yourself. You could, if you or your employer are willing to put up the money for you to travel to Oulu or Hawaii or wherever it's being held. Chicago, I think, was the most recent one. They hold it all over the world because this is an international standard, and it would be very unfair if it was held in Nebraska every year, because then the people in China would have real trouble making it. So they change it all the time. So you make it to the committee meeting, and using your advanced social skills, you will convince them to schedule it, because they actually need to talk about it, and there is a schedule. So you'll convince the appropriate committee or subcommittee that it needs to be talked about. Now, this is where we get into the structure of the committee, which is really important because you don't want to have your proposal sent to the wrong committee and then they're like, sorry, come back next year. So the standard committee is sort of broken up into two branches. There's the people focused on the library and the people focused on the core language.
Right.
And each of those two branches is split into an evolution side and a implementation side, you might say. So, for example, there's evolution and core, which are focused on the language, and there's library evolution and library. They work on library proposals.
So were you under library evolution, I guess?
Yes.
Okay.
So the way that works is, I was under the library branch, if you will, and your proposal starts out at evolution. If it makes it through the evolution committee, then it goes to the library committee.
Oh, okay.
If it makes it through that, then there's more steps along the way. But you'll see, there's sort of a two-phase process. The idea being the evolution committee will decide if your proposal is worthwhile, if it's the right shape, if it needs to be rethought, or if they've just got general feedback. The idea is to sort of like a high-level, high granularity filter, or low granularity filter for filtering out all the cruft.
Mm-hmm.
Right? Try to get things in a reasonably good state to pass on to the next phase. So once you make it through there, and they'll decide things like the right name to give to your functions, what sort of exception guarantees will typically be decided there. They'll get all the high level stuff usually. In the next committee, they'll decide all the low level stuff. What's the correct wording to make it into the standard? And this can be a really tough process. They'll decide, is this even implementable? Maybe it's not. Because, at least in evolution, there's all sorts of people in evolution. But when you reach core or library, you're locking eyes with the people who have to implement your feature.
Right. Compiler writers, standard library implementers. They're going to be there and they're going to furrow their brows at you if your proposal has got some problems. So, hopefully you make it through all that process. For me, I went through four revisions of my proposal, and most of those were sort of like internal revisions that weren't like seen by a committee. But so what ended up happening for me was I had a champion go to, I believe it was in Hawaii, to get my paper through evolution. And then it was at the next committee meeting that I attended where it went through library. So it was a two meeting process. Okay.
That's almost ideal.
Yeah.
It's very rarely going to make it all the way through in one go. That would pretty much be unheard of. Which can be, a bit of a problem if you're self-funding and you have to attend 3 or 5 committee meetings, to get your paper through. It's not great. But, for as much criticism and negativity as you might hear there, I totally understand why they have this process. It makes sense. There's only so many people in the process, so I'm not criticizing the committee. They're great people and they're doing great things, but it is a little bit like going through a meat grinder. At least, definitely for someone who's new to the process.
Sure.
It was hard. Anyways, you've made it all the way through this subcommittee. You're still not quite done. So the subcommittee, like the library committee or the core language committee, have decided, okay, we want your feature and we also want all these other features. And then at the end of the meeting, they say, okay, guys, here's all the features and bug fixes that we've decided we want for the next draft of the standard. They'll go through them one by one and say, we want uninitialized memory algorithms. Anyone want to vote against it? And this will be everyone who attended the committee, people from all sorts of backgrounds. You'll have members from national bodies. So the guy representing Czechoslovakia for C++ will be there and he'll have a chance to vote against it. The people representing Google and Apple will all be there with a chance to vote for or against. And the goal there is to achieve consensus. Consensus, I don't think, has a very strict definition. So my approximate guess would be around 2/3 counts as consensus. So if about 2/3 of people vote in favor of your proposal, then it's in. Sweet. Yeah, so that's more or less the process. There can be a little bit extra. There might be merge conflicts. And the editor of the standard will help you with those merge conflicts. After that, there can be bug reports filed from national bodies saying, we really hate this feature, or we will vote against the feature unless you accept these changes that we propose. That can happen. And then finally, at the very end of the process, all of the most important stakeholders from the various national bodies get together and make a final vote. This will be the next version of C++. And that is how an idea becomes a standard.
So how important was it for you to have an implementation ready to prove to the implementers that this was possible and useful?
Yeah, I think they're becoming really strict about that. Here's the thing. If your idea is really simple, then you should be able to implement it very easily.
Right.
Like mine. Mine was just a couple of functions, no big deal to implement. You could, writing the functions was like 15 minutes, and getting it into the standard was weeks of my life. So, if you're writing a simple proposal, that's almost without asking. You should definitely do it. But on the other hand, if your proposal is really complicated, you also have a high burden of proof. And you also need a good implementation because there's more risk with something that's complicated. There was a time when maybe they weren't so strict about this, and that's how we got export templates. So they're really afraid of putting something in the standard that can't be implemented or that has unexpected consequences and side effects. That's happened a number of times. Something almost made it into the standard, and they realized, hey, if we put this in, it will screw up all this other stuff we're working on. And they just realized it at the last minute. That can be real danger.
Wow.
So implementations are super important. They're getting more and more strict about that, I think. And it's one of the bottlenecks in a lot of ways that, if we had 7 or 8 implementations of coroutines, we probably would have had it years ago. Mm-hmm. But, they need good proof. They want, basically the standard committee wants to play with your feature to make sure that it behaves in a reasonable way. They want to be able to put breakpoints in it and see the performance and the code gen. All that stuff you need an implementation for it. So it's huge.
Makes
it's really
sense.
huge.
Yeah.
But it's a huge burden too, though.
Yeah.
And it means things get delayed because, we could have put modules in 5 years ago, but without an implementation, you're undertaking a huge risk.
So I guess if you could give like one piece of advice to someone who's hoping to get something in the standard, what would you say?
Make friends.
Okay.
Yeah, I mean, having as many friends in the committee as you can is important, because unless you're part of the committee, you're probably not going to be able to attend every single committee meeting where they might discuss your proposal. If you're not there, they might not schedule it to be discussed, or if there's someone there if there is no one there to defend it,
Right.
They may not, have a lot to talk about. So if you can have champions there to help you, if you can make friends within the committee, so they'll be a little bit more accepting of your personality quirks. Maybe you won't offend people as much if you're friends with them, and the whole process will go a lot smoother. So, as programmers, we like to think that we're immune to, social whimsies and emotions. But when you put so many people in one room or in a few rooms, it's important to have some friends and some social skills to help guide you through the process, because especially if you're new, you're not going to know what the heck's going on. So that would be my recommendation.
All right.
Okay. But before we let you go, I know when we were talking earlier, you mentioned you had this project to convert Microsoft PDB into SQL. Do you want to tell us a little bit about what that is?
Yeah, so this is a fun little project, sort of side thing I've worked on. So the way this worked was there was a blog post I saw a few years ago for a project made by Adrian Stone, and I'll give you guys links for this.
Sure.
This is a project called Symbol Sort, and what it does is sorts all of your functions according to size. So you can see what are the largest functions in my program according to bytes of executable code.
That's pretty cool.
Yeah.
It's really cool. And it's got a number of uses. There's just sort of the optimization thing. Like maybe if your hot functions are listed as the biggest ones, you've probably got a problem.
Yeah.
Or if you've got one function that's like a total outlier, it's like 10 megabytes and all the others are half a kilobyte.
It's worth looking at.
It's definitely worth thinking about. But it can also have a huge effect on compile time, because those huge functions can take forever to compile.
Yeah.
Often the biggest functions are going to be auto-generated with macros, X macros, or some system like that. And you don't realize that you have a huge function because it's all hidden behind abstractions of preprocessor stuff. So this can sort of reveal that hidden cost that might otherwise not be available to just looking at the source code. So this was a really cool project, and I sort of looked at how it was implemented, was really interested in it. He's using an API, Adrian. I think Adrian's he. I don't know, actually. The implementer of this program made a really cool thing, and it was using Microsoft's DIA API, the Debug Information Access API, which has access to pretty much everything that the debugger has access to. In fact, I think the debugger is implemented using DIA. So I realized there's tons of data that he's just throwing on the floor. He's just grabbing the functions and the size of the function, but there's so much more information available to the linker, which is effectively what the PDB is. It's all the linker information, or all the information generated by the linker about your program. It has information about your class hierarchies, about your virtual function tables. It has information, of course, about all your functions, but at least for the PDB format, it goes as detailed as, hey, this function calls long jump because that affects the linkage, or how the linker, like prolog, I guess. So you can say, there's so much information in here, and I wanted access to it. I'm like, hey, this is really cool. So my idea was, hey, let's take this PDB format, which is really hard to get information out of, and stick it in a MySQL database. So then you can just perform arbitrary queries. Adrian's program here lets you sort all functions by size. That's a very simple SQL query. Select all functions, order by size, right? But now you can do a whole bunch of other stuff. Like you can say, find all data types that are bigger than this size. Find all data types that have more than 100 entries in their vtable. Select all data types, and then use that to form a graph. That's an example I have on my page, on my GitHub page. is I took the output from my database and used it to generate a graph, an inheritance graph of my entire program.
That's cool. Pretty cool. Yeah.
Yeah, there's a lot of cool stuff you can do with this. It's very similar in a way to Clang tooling. Clang tooling lets you have access to a lot of information about your program, but it works at the translation unit level. It works file by file, basically.
Okay.
PDBs work at a whole program level.
Right.
They're sort of the linker version of Clang tooling. So you have the final version, you have the optimization info, you have the address of each function, you have all sorts of platform-specific information, as well as the global analysis of relationships between things. So it's really, really interesting, useful. It's also sort of prototyped because Microsoft's their documentation of DIA isn't great. Their API is way worse than not great. It's pretty rough. I've actually, in my program, I have built a subroutine for trying to generate documentation for the Microsoft API just because I was unhappy with it. So I call every function on every symbol I can find and try to figure out what functions are valid in what contexts. Just because the API doesn't make that very clear when it's okay to call this function and when it's not.
That's funny.
So, yeah. So what I'm getting at with that is that it's, it's not perfect.
Sure.
And I don't really know what I'm doing. I'm kind of fumbling around, but there's so much data that I've been able to get out of it. And I would love to see some contributions if people are interested in what we're doing here, because, I would love to see this thing have access to everything in the PDB. And see what kind of things people are, do with it.
Yeah.
Right.
Well, we'll put a link to that in the show notes. And I know we have some listeners from Redmond, so maybe they'll hear your comments and work on that DIA documentation.
Okay. I can't wait.
Yeah. Okay, so Brittany, where can people find you online to find more information about this project and all your other work?
Yeah, so I have a Twitter. It is at ListenServer, and GitHub will be in the show notes. So, give me a tweet, send me a link. I would be happy to interact with the whole of the C++ community. I love you, beautiful people. So let's get out there and write some code, right?
Cool.
Sounds good. Okay, thank you so much for your time today.
Thank you.
Yeah, thanks for joining us.
Thanks so much for listening in as we chat about C++. I'd love to hear what you think of the podcast. Please let me know if we're discussing the stuff you're interested in. Or if you have a suggestion for a topic, I'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. I'd also appreciate if you like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at LeftKiss on Twitter. And of course, you can find all that info and the show notes on the podcast website at CppCast.com. Theme music for this episode is provided by podcastthemes.com. Website at CppCast.com. Theme music for this episode is provided by podcastthemes.com.